Hello guys, this video is going to be on estimation. Hope you enjoy. So the first thing we're going to talk about is the population parameter. So a population parameter is just any property of a distribution. This can be something like mean, range, or median. But not all of these parameters are created equally. Some are what's called biased, and some are unbiased. Now, to illustrate this point, let's think of some ridiculous outlier. If we were to add in a ridiculous outlier to a set of data, it would wildly skew the mean, probably pulling it way above what the actual population parameter is. And so this is a biased parameter. Range is the same. If you were to add a ridiculous outlier, it would incredibly expand the range, probably beyond what you would expect for the population. Median, on the other hand, would be unaffected by such a large outlier, and so we call it an unbiased parameter. The margin of error is a little more mathematical, a little more technical, if you remember it. For a proportion, it is given by the z critical value, square root p hat, 1 minus p hat, and if you don't remember what all these mean, over n, then we'll explain a little later. For a mean, it is given by T S, where that is the standard deviation of the sample over square root n. So now let's talk about a little bit of the logic of confidence intervals. So a confidence interval is created using a margin of error and a point estimate. So it's the point estimate plus or minus the margin of error. And so when we talk about a confidence interval, what we're basically saying is that we're to take an infinite number of trials, get an infinite number of points, about X% of them would fall between the interval X, Y. So if we had a 95% confidence interval, then if we were to take an infinite number of trials, 95% of the point estimates we get would fall between this confidence interval. Now, to even create a confidence interval, we need to satisfy a couple of conditions. The first one is random, which is hopefully given to us by the problem. The next is independent, which we can determine using the 10% condition. And the last one is large counts. And if you remember large counts, there has to be greater than 30 samples in the data to satisfy this. Next is the interpretation of a confidence interval. So this is a little bit the same of what the last slide is, but we're going to give you some more specific language. When you want to interpret a confidence interval, you say that we are X% confident that the interval from X to Y captures the parameter in context. A little bit the same of the last problem. Now let's talk about determining critical values. So when it comes to proportions, if you remember, we're using that Z critical value, and that's found down here on this last line. Some charts show it as an infinity, and basically you come over to here to what you want. Like let's say we want to be 95% confident, well then you take this critical value and you enter it as the Z value. For the mean, remember we use T, and for T we need something called the degrees of freedom, which in this case is equal to your sample minus 1. So let's say our sample is 10, well our degrees of freedom would be 9, and if we still wanted to find that 95% confidence interval, we'd come up and use this. So now if we want to determine a sample size using the margin of error, we're going to rewrite that equation. For proportions, we'll be given the Z constant, or they'll tell us we want it to be 75% confident. Then we're going to use 0.5 as p hat, because that will give us the largest margin of error. And then we can solve for n. For means, the t, we are going to use the z value in its place, because you need to know the degrees of freedom in order to find the t, but you don't know that if you don't know the population. And for the rest, that's the s in sample, and you just solve for n. And here's a good AP question for you to practice on your own. Hope that video helps, and good luck.